g'day, welcome to another biology revision stream. So, last week I promised you guys that I would be trying to do one of these streams every day. I did not, so I'm gonna remake that promise. I really hope that I can try and stay consistent with these revision streams, because it is getting very close to exams now. If I check my calendar, the first biology exam is the 5th of June, so that gives us just under 3 months for that exam, or basically 2.5 months. But my first actual exam is history, which is only 2 months and a week away. So what that means is we really need to try and lock in now. We really need to try and get these streams going. I am going to be trying to lock in to school, make sure that I'm doing as much as I can. And hopefully these streams are going to be a great way for me to do that as well. So, I'm just going to try and find the past papers for biology, because what I thought we would do today is try a paper 2 again, but I also wanted to throw in a paper 3. So we'll look at paper 3 first. So I don't know what a paper 3 is. I don't know what it's really focused on, but let's have a look. Describe how stimulation of a Pacinian corpuscle produces a generator potential. Oh, okay. That was not the first question that I was really expecting. That is paper 2 content, 3 marks for a Pacinian corpuscle. So, obviously, we know the structure. It's going to be that cell, and then it has, obviously, it's going to have the axon terminal. But the whole gimmick here is that when pressure is applied, it is going to cause the stretch-mediated Na plus channels to open, causing sodium ions to diffuse in via facilitated diffusion. As more sodium ions enter, it will cause positive feedback where more channels will open if the stimulus is large enough. So, how are we going to phrase this? We are going to say, firstly, when pressure is applied, it's going to cause the stretch-mediated Na plus channels to open. I guess we should specify some. This causes sodium to diffuse in, or facilitate diffusion into the, what would it be? The cell? What's the name of the cell? What is it called? Because you have the cell. I forget it. I'm just going to say that it diffuses into the cell. And depending on the size of the pressure, more will open up in order to accommodate. And this will create a generator potential if the threshold potential is surpassed. So let's look at what it says here. Stretch-mediated sodium ion channels will open, sodium ions diffuse in. That's all we needed to say. Okay. All we needed to say was there are stretch-mediated sodium ion channels. They will open. That is literally 2 marks. And sodium ions will diffuse in. We could have really easily summarized this third bullet point here by saying that it causes depolarization in the cell, because that's what happens. So that is 3 marks. I'm going to count this. We are going to keep track here. 1, 2, 3. We'll keep track. So, let me show you what I mean. We have a graph like this. Action potential. I guess we can kind of draw what would happen if the stimulus is not sufficient enough. So that right there is depolarization. That is repolarization. This is hyperpolarization. And this whole thing here is the refractory period. So basically, to summarize an action potential, when the stimulus occurs, it's going to cause sodium ion channels to open. Depending on the size of the stimulus, the intensity, if that stimulus is large enough, it will cause enough sodium ion channels to open where it will surpass the threshold potential. And that is the all or nothing potential, basically. So if it'll either go all depolarize or nothing, repolarize, refractory. So that is basically it. That is basically how it works. So depolarization is a very good word to use, but I forgot to use that. I started yapping about generator potentials and whatnot. No, literally nothing. I might have even lost a mark if I got that. No, I wouldn't have, but still, I probably, if I was being incredibly strict on myself, which I usually am, I would have only given myself 2 marks there, even though I ticked everything in the mark scheme. Oh shit, I just spoiled the next question. Scientists investigated the stimulation of a Pacinian corpuscle in the skin of a fingertip. The scientists applied 2 different pressures to the fingertip and recorded the changes in membrane potential of the Pacinian corpuscle sensory neuron. So I guess I'll try and draw this graph out. It's a very simple graph. Literally showing, if I can actually draw. Like that. So this is obviously high pressure. This is low pressure. Use figure 1 to describe what is meant by the all or nothing principle. Okay, we've just talked about this, so hopefully I can actually reiterate what it means in words. All or nothing principle is an action potential will only be triggered. Again, while I'm writing on the whiteboard, I tend to abbreviate things. I won't obviously do that in the exam. I just do that to save time because I'm writing on a whiteboard, just for clarification. The action potential will only be triggered if the stimulus is significant enough. To be honest, I don't actually know what else you would put there. Because that is basically it, right? The action potential is only triggered if the stimulus is significant enough. Would you talk about charges there? I'm not sure. Would you talk about charge? Could you say, like, if... Would you talk about depolarization there? I don't think so. Let's have a look. An action potential is only generated when the threshold is reached. I didn't mention the threshold. Shit, I didn't. When high pressure was applied to the fingertip, the threshold was reached. High pressure generates... Oh, okay. So I don't know if I would have gotten a single mark here. I'll tell you why. It said use figure 1. That is a very deceptive question, though. Use figure 1 to describe what is meant by the all or nothing principle. But it's not asking you to describe it for figure 1. Like, it's not asking you to use the context. That is weird. Because that is an annoying question. That is an annoying question. I probably wouldn't have gotten any marks there because I didn't mention threshold potential. The action potential is only triggered if the threshold is surpassed. Or the threshold is reached, sorry. So I'm going to try and drill that one into my head. Usually I add like notes to the bottom here, so I'm just going to put the action potential only triggered when passes threshold. When the threshold is reached. So that is a very simple definition. The all or nothing principle is when the action potential is only triggered when the threshold is reached. But that could be worth like a mark or two there. So all I would have needed to do realistically is remember that, and then I would have had to apply it to the context of this graph, which would have been piss easy. The higher the pressure, higher pressure will trigger the all or nothing principle. The lower pressure will not trigger the all or nothing principle because it does not reach the threshold. That would have been an easy 2 marks, but I don't think I would have gotten either. Which is fine, because we know now. On figure 1, from 0.6 milliseconds to 4 milliseconds, no new generator potential could be produced. What is this time period called? That's the refractory period, correct? Yes, the refractory period. And you would have had to specifically say refractory. You could not say refraction, which is fine. I don't call it the refraction period. Oh, this is a practical. A student investigated... We've done this practical. A student investigated the effect of different sugars on the rate of respiration in yeast. Yeast normally respires glucose. So, she completely filled a small test tube with yeast and glucose. She pushed the small test tube up a larger test tube. She inverted the larger test tube and placed it in a water bath. After 25 minutes, she measured the length of a bubble of CO2 produced in the small test tube. Okay. I'm just trying to visualize this in my head. So you would get a test tube, like a big test tube. I don't know how, I just kind of draw them like large U's. You get a test tube, and inside this test tube is a larger upside down test tube, like so, with the glucose and yeast. So, there is no liquid in this or anything. It's just a larger test tube. Then this is literally placed in a water bath at 30 degrees Celsius. And it's left for 25 minutes. Okay. That's fairly easy then. So obviously we have this upside down test tube here, filled with glucose. After 25 minutes, some of that glucose is going to be used, and there's going to be a CO2 bubble, because CO2 is produced as a byproduct of respiration. Yes. Okay. Other than those stated, suggest 2 variables the student needed to keep constant. Okay. Should we give some obvious answers and hope that they work? Because the obvious answers I'm thinking of would be, the obvious answers I'm thinking of would be, I guess, I don't know, I had one in my head, but I've lost it now. I'm gonna say type of yeast, maybe? Are there different types of yeast? I actually don't know. She completely fills a small test tube with yeast and glucose. She put it in a water bath, so we obviously can't specify temperature or time. They've already been given. We could say like the volume of test tube or quantity of yeast glucose solution, or I guess vol of yeast / glucose solution. And should we say like type of yeast? Will that count? Or should we say like size of test tube? Size of small test tube. Let's just look. Concentration of yeast, concentration of sugar, volume of yeast, volume of glucose sugar. Okay, so I could have literally gotten both marks for saying volume of yeast, volume of sugar. So you know what? I'm gonna give myself a sympathy mark there. Because I feel like in an exam I would have put one rather than both. Size of test tubes was one as well, actually. So you know what? I'll happily give myself both marks for that. And you can't say amount, so you had to say volume, so that's good. Shows the result she obtained for yeast and glucose solution. Use figure 2 and figure 3 to calculate the rate of CO2 production. Calculate the rate of CO2 production in millimeters per second for yeast and glucose solution. Give your answer in standard form and 2 significant figures. So, that is going to be approximately 6.9, 6.8, 6.7. We are going to say 6.5. 6.5 to 10, which is going to be 3.5. Is that centimeters? Or 35 millimeters. Oh, one sec. Okay. So that is 35 millimeters produced in 25 minutes. 25 minutes multiplied by 60 to get the time in seconds. I'm going to have to... Oh, holy shit. I have not done long multiplication in a good while. What the hell? Is that... You know it is bad when I forget how to do long multiplication. Jesus Christ. Okay. That is 1,500 seconds. So we are saying 35 millimeters divided by 1,500. That is likely going to give us a big answer of 0.023333, recurring, which in standard form is going to be 2.3 times 10 to the power of minus 2? No, minus 1. Feel like I've done that wrong, because that is a very weird... No, because I brought it in wrong. From a calculator. 2.5 times 10 to the power of minus 2. So I was off somehow. I was off. I think I misread the scale. I think that was my mistake. I think I misread the scale. Which it did allow you to do. You were allowed to misread it. Oh, I'll tell you why. Because it went up to 10, but then it also went up to 10.4. So I bet you it was 3.9. Which would get you... What should be correct? 0.26. So I would have been correct had I taken more time. That is still a mark. That was a nice math question. Compared to the kind of questions you get asked in biology, that was one of the nicest questions I've ever seen. Oh, where is Ethan when you need him? Because his next question would like... He would like this next question. The student repeated the experiment using yeast in maltose. She found the rate of carbon dioxide production was slower, suggests why. Maltose. Okay, hold on. Let me remember. Glucose plus glucose. Glucose and fructose. Glucose and galactose. Glucose and galactose is lactose. Glucose and fructose is sucrose. That means glucose and glucose is maltose. Okay. Why would it take longer? Because maltose is a disaccharide, meaning that time is taken for enzymes to hydrolyze maltose into glucose so that it can then be used as respiration or used in respiration. That is a good answer, right? Maltose is a disaccharide, meaning that time is taken for maltose to be hydrolyzed into glucose, which can then be used in respiration, meaning that the rate is slower. Maltose is a disaccharide, time to be hydrolyzed into glucose, 2 marks, easy. Just as long as I specified that time would be taken. Would I have gotten a mark? Yeah, times to break the glycosidic bonds, which I also would have mentioned. Nice, very nice. We're doing okay so far. A second student used a different method. He set up a tube with yeast in a glucose solution and added bromophyllium. What the fuck? Bromophyllium. What? Bromophylmol blue. Bromophylmol. What the fuck? I'm just gonna call it blue. Blue changes from blue to yellow when CO2 is produced. To determine the rate of respiration, he timed how long it took. Suggest why this method would be less accurate and how the accuracy of the method could be improved. 2 marks. Why would it be less accurate? Because a colour change is subjective. So it will be different for every person. To improve, you could use colorimetry to create a calibration curve to, compare. Oh, so, no. Sorry, I'm yapping. I'm trying to fill up the word count. You would use colorimetry because it would give you a quantitative result over a qualitative. Colour is subjective. Use a colorimeter. Have a colour standard as a reference for the endpoint, or have a colorimeter so maybe you would have gotten both marks. I'll give myself both, because I feel like that is fair enough, honestly. It's the link reaction! Oh, I love the link reaction. The link reaction. Oh, what a paper. I would love this paper if I got it. What the fuck? Acetate into acetyl coenzyme A. That would be because coenzyme A bonds. That is NAD into NADH, or reduced NAD. This is pyruvate. A is pyruvate, B is NADH, C is coenzyme A, D is acetyl-CoA. Oh, there we go. Nice. How many marks was that? Because that was a piss easy question. 2, okay, hell yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 out of 16. I'm happy with that so far. How many marks is this paper out of again? Wasn't it like 70 something? $78? Hell yeah. Oh! Below are 4 statements about the structures of prokaryote DNA. Which statements are correct? No prokaryotic cell has DNA that is associated with proteins. That is correct, because they are not associated with histones. So that would be correct. 2. No prokaryotic cells have membrane-bound organelles. Isn't that why they're called prokaryote cells? Because they have no membrane-bound organelles? We'll come back to that one. All prokaryotic cells have one or more flagella. That is false. Not every prokaryote has a flagella. That is wrong. That is incorrect. All prokaryotic cells have smaller ribosomes. Yes, they have 70S ribosomes compared to the 80S ribosomes. 70S ribosomes are also found in the mitochondria and the chloroplasts. The more you know. So, I'm going to say it is statement 1, 2, and 4 that is correct, because all the others contain 3. 3 is not correct. So by logical reasoning, it has to be statement B. Correct. Yay. Man, this would be an easy as fuck exam. What the hell? Watch me say that, right? Watch me say that right now. Watch me say that. And then this next question is going to be like piss difficult. A student investigated the effect of 2 oh, what the fuck? That is a massive wall of yap. Oh no. Calculate the mean number of bacteria in the undiluted bottle of liquid culture containing the novabication. Novabication? I don't know. Novobiosin. Okay, that's how you pronounce it. The undiluted bottle. That is a weird-ass math question. Hold on. So would you have to multiply it by 100,000? The mean number of bacteria. So would you literally just do... Would you literally just do 238, 263, 261? Obviously calculate the mean of that, which I'm not going to fully answer this, so let's just use inference here. The mean of that, I'm going to assume would be like 245. I could pull up a calc and see. I kind of can't be asked, but 263. If this is actually correct, it won't be, but why is this calculator so shit? 254. Okay, I got both numbers mixed up. Okay, so that's the mean. So then would you not literally multiply it by 100,000? Is that what I'm hearing? 100,000. 1, 2, 3, 4, 5. 25.4 million? Oh, but give it in standard form. Okay. 2.54 times 10 to the power of 1, 2, 3, 4, 5, 6, 7. Is that correct? Hold on. 1, 2... Yeah, that's correct. Okay. Well, that's the answer that I've got, but is it correct? No, it is not correct. Interesting. $914... Have they not calculated the mean, then? Correct answer of 914 million. I must have misread something in the information. After 24 hours, he diluted the contents of each... Transferred 9 centimeters of liquid culture. Shit! Okay. This only accounts for 0.25. So we would have to multiply this by 4, and then multiply it by 9. Or in other words, multiply it by 36. That still wouldn't give you a right answer though. Hold on. That would give you like 800 million. Hello? Two, 5, 4, 0, 0, 0, 0, 0, times by 4, times by 9. 9144. Yes, okay, I did it. Fuck you. Okay, I figured it out. I did get it wrong the first time, but I figured that out. Okay. Fuck. I figured it out. That was a good math question, because, yeah, you would easily misread that. It said transferred 9 centimeters cubed of a culture, but then he transferred it into 0.25 centimeter cube samples. That is such a deceptive question, because you would easily get that wrong. Starting with a single bacteria, Calculate how many generations it would take to produce at least the number of bacteria you have calculated. Oh. You could use the integer or log button to calculate your answer. We have never been taught how to use the log button. I could try it though. I could try and quickly learn what it does. So hold on, if the answer was 914 million... Just realised I haven't checked it. Right, if I do log... I don't know how the log button works. I don't know what I'm doing. Log something something. But if I put 1 there, I'll figure out how the log button works. We'll do it. Got a math error. Is it 29 or 30? Yes, 30. Okay, I figured it out. You just put 2 in the small one because it's multiplying. It's squaring every time. That's cool. Okay, I didn't know the log button had a use, but there you go. That's cool. Yay. M. luteus is not resistant to chloramphenicol. Suggest 2 reasons why the bacteria were able to grow. I'm gonna say random mutation led to a resistance. Or I don't know. That's only one reason. Random mutation. Mutation occurred, or the concentration was too low to kill them all. Cool. I would have gotten a mark. Just gonna give myself 2 marks there, though. Bro, there were people that actually would have taken the time to figure out how many generations it would have taken. Oh my god. Final question I'll do, and then I'll probably head off, because it's been about 40 minutes. Following a body injury, bone marrow... we haven't done stem cells yet properly, so we'll skip that. Scientists investigated the effect that the release of heated water into a river from a power station had on the effect of biodiversity on a local fish community. They measured the species richness. So species richness is it just the number of different species living in an area? Number of different species living in same area. So, by that logic, it is showing that the species richness is staying about consistent to 40, but it's showing that the index of diversity itself kind of is dropping and then going back up. Started at 6, but it seems to be drifting to 4. They used the Simpsons index of diversity formula, which years, in some years the values were n equals 624, which years have these values. So where n is the total number of fish of all species. So would I just do... Shit, what years have these values? I don't know. Why is this a 1 mark question? That feels like it should be a 6 mark question. Index of diversity. If the index of diversity is 4, then that's going to be 3, that's going to be 12. Okay, hold on. N minus 1 equals 6, 4, 7, 9, 2. I could just use a calculator to figure that out. Because we could easily just put, like, C equals... Oh, sorry. 6, 4, 7, 9, 2 equals B minus 1. And then we click solve. And it says B is minus 2. Right, that's obviously not correct. 254. I have no idea. I don't know how to figure this one out. Can we get some help, please? It's saying 1982 and 2003. 1982 is where it's at like 4.5. I would have no idea how you figure that out. Oh, that would be where it's at 6. The only 2 years to reach 6. So now I'm wondering, how did they reach 6? Some years n equals 624. Oh, because I did the math wrong. Okay, I am gonna wrap up this stream because I am obviously getting tired and stuff. But okay, that is helpful to know. That is interesting. So, this has been a good revision stream. I am happy to say that I feel a bit more confident now with paper 3. Because I was heavily under the impression that paper 3 would literally just be nothing but practicals. But you had that very nice question right at the start. You have a question about the length cycle. You had a few very nice math questions. You had a couple difficult math questions where you could easily get caught off. But overall, I'm pretty happy.